Hello, good morning. This lecture is on first order systems in series. We have studied about individual first order systems. We have studied many examples. How to derive the transfer functions, what are the transfer functions, what are the how is the dynamics for different types of inputs. So now we will see about study about first order systems in series. That is when you connect two or more first order systems in series, what happens, what is their effect. When two first order systems are connected in series, they can be either non-interacting or interacting. So they can be connected either in a non-interacting way or interacting way. So what is the meaning? What is non-interacting? What is interacting? So that is what we will study in this lecture. So this lecture will consist of these three topics. Number one is concepts. Concept is what is the meaning of non-interacting and interacting. See what is the meaning of interacting and interacting, sorry, non-interacting and interacting. Then how do you write the transfer functions? Then third, what will be the dynamics, the response. Dynamics means the response for different types of inputs. So we'll study this for both non-interacting and interacting. So for this we will take an example of simple example. We will illustrate this. The entire lecture will be illustrated using an example of a first order system. We know simple liquid level in a tank is an example of first order system. So just to refresh, this is the tank through which a liquid is continuously flowing in and out. So there is a continuous flow of liquid in, liquid out. Q is inlet volumetric flow rate and Q naught is the outlet volumetric flow rate of the liquid. H is the height of the liquid in the tank. Okay. So this liquid flow, outflow, is entirely due to the liquid level in the tank, that is height of the liquid in the tank. So the driving force for the liquid is this head. And we also consider that there is a resistance for the entire flow denoted by R, which is located in the outlet. For every flow there will be a resistance. The resistance we denote by R. So the outflow Q naught, volumetric outflow Q naught, will be a function of this height H and the resistance R. Okay. So Q naught will be a function of H and R. So there can be different types of relationships depending on what type of outlet you have and what type of flow is this. So there will be different types of relations. So for a simple relation, simple case, we call it as a linear relation. Simple relation is straight linear. Q naught is H by R. That is, outflow is directly proportional to the height, liquid height. So in our lecture also we will use this example with linear relation. Okay. So with this example of tank, let us proceed further. Now if you take two tanks and see how they can be connected. They can be connected in two ways. So one is this as shown in this figure, and another one is this way, figure 2. So what is the difference between these two? These two methods shown in these two figures. This is first and this is next. So let us see the difference, what difference it makes and how it alters the dynamics. So in figure 1, the liquid outlet from the first tank, this, flows directly into the second tank over the level in the second tank. The liquid outlet from the first tank discharges into the second tank over and above the level of the liquid in the second tank. So this is the connection. Now, because of this, how do these characteristics of each tank, what will be the characteristics of each tank as far as this flow head relationship is concerned? Now for the second tank, the outlet flow Q2 will be a function of this H2 height in the second tank and R2. Q2 will be a function of H2 R2. So if you consider a linear relationship, Q2 will be equal to H2 by R2. And for the first tank, the outflow depends on the resistance of this first tank and also level in the first tank only. So Q1 will be a function of only H1 and R1. And for a linear relation, if it is a linear relationship is obeyed in this tank, then Q1 will be H1 by R1. So we see that the flow head relationship of first tank does not depend on any way in the anything on the second tank. So if there is a disturbance in the level of the second tank, it is not going to affect the flow of the outflow from the first tank. I repeat, if there is any disturbance in the second tank, suppose the level of the second tank H2 changes, then it is not going to affect Q1. It is not going to affect the outlet flow from the first tank. It is not going to affect the level in the first tank. So the response of the first tank is not affected by any disturbances in the second tank. The response of the first tank, that is either Q1 or H1, is not affected by any disturbance in the second tank. So this type in this type, the two tanks are said to be non-interacting with each other. The two tanks, or let us go to the general definition. The two systems are said to be non-interacting with each other. So what is the meaning of non-interacting? If the response of the first system is not affected by any disturbance in the second system, then we call them as non-interacting systems in series. So even though illustrated with respect to tanks because it is easier to understand, so this definition is true for all systems, all first order systems connected in series. So two systems connected in series are said to be non-interacting if the response of the first system is not affected by any disturbances in the second tank. So that is the meaning of, that is the definition, that is the concept of non-interacting systems in series. So what is written here, if you replace this tank by system, you get a general definition. You replace the word tank by the word system. So it will be, this definition will be true for any system. Okay, so this is the meaning of non-interacting systems in series. Now let us see the other figure. So here what happens? Here the liquid outlet from the first tank is connected to the bottom of the second tank. You can see the difference in this figure, how this figure differs from, how the connection in this figure differs from the connection in the previous figure, figure 1. So the liquid outlet from the first tank is connected directly to the bottom of the second tank. Now if you see the how the flow depends on the head and resistance. So let us take second tank. For the second tank, Q2 will be a function of this H2 and R2 as before. So Q2 is a function of H2 and R2. A simple case, Q2 equal to H2 by R2, linear. Now if you consider if you look at the first tank, so here the outlet depends not only on H1, that is level in the first tank, but also it depends on the level in the second tank. The outlet flow of the first tank depends not only on H1 but also on H2, and of course the resistance R1. So Q1 will be a function of H1, R1 and also H2. Or if you take a linear relationship, Q1 equal to H1 minus H2 divided by R1. So if H2 is more, Q1 will be less. If H1 is more, Q1 will be more. So here Q1 depends not only on H1 but also on H2. So the dynamics of the first tank is affected by the disturbance in the second tank. Is it not? The dynamics, the level, for example H1 and also Q1 will be affected by the disturbances in the second tank. If H2, there is a change in H2, then that is going to affect H1 as well as Q1. So that is what it says here. The dynamics of the first tank is affected by the disturbance in the second tank. So the two tanks are said to interact with each other. The two tanks are said to interact with each other. And this is known as interacting systems in series. So again, replace the word tank by the word system, you get the general definition. Two systems are said to be interacting if the dynamics of the first system is affected by the dynamics of the second, by any disturbances in the second system. I repeat, two systems are said to be interacting if the dynamics of the first system is affected by any disturbance in the second system. So this is what we call as interacting systems in series. So I used to ask these questions to many students. What is interacting systems and what are non-interacting systems? Most of the time, the answer I used to get, 95% of the answer I used to get is, sir, in a non-interacting, the liquid outflow from the first tank is discharging into the top of the second tank, whereas in interacting tanks, the liquid outlet from the first tank is connected to the bottom of the second tank. So this answer I got most of the times, 95% of the time. So that is not a very correct answer, because the answer relates only to the way the two tanks are connected. The answer says how the two tanks are connected, and why we call it as interacting or non-interacting, because of the way they are connected. So that is not given by the answer. And moreover, these tanks are only an example we have taken to illustrate this process, this interacting and non-interacting systems. So the general definition for non-interacting interacting is what I have discussed just now. Two systems will be said to be interacting if the dynamics of the first tank is affected by any disturbance in the second system. Okay, if the dynamics of the first system is not affected by any changes or disturbance in the second, then we call it as non-interacting. I hope the difference between the concept of interacting tech systems and non-interacting systems is clear. What makes it, why do we call this interacting? Interacting because the two systems said to interact because the second, if any disturbance is happening in the second, any disturbance is happening in the second has a bearing on the first. Okay, so we'll see more in the next part, how to write the transfer functions and how to find the response in the next parts. So your comments are welcome. If any comments, questions, you can leave it in the comment section below. See you in the next part.